Hello and welcome to this episode of T-Tech. On today's episode, we're going to show how to set up a lab network to separate off your lab devices from your production network while still giving them internet connectivity. I do hope you enjoy this one, and let's get into it. Hello and welcome to this episode of T-Tech. In today's episode, we're going to show how to set up a lab network with Cisco equipment. So, today I have a Cisco 2600 series router in my lab rack. And what I want to do, since I do a lot of things with equipment that I don't want exposed to the internet, but I still need internet connectivity with it, I can set up these machines to have a separate lab internet connection. But it still has real connectivity through my existing production network. So that's what we're going to do today. We're going to say no to this initial configuration dialog. And first thing I want to do is, it's a little bit, it's real equipment we're consoled into, so it's a little bit slower. We're going to do enable. And we're going to go configure terminal, conft for short. First thing I want to do is do show IP interface brief. And I want my fast Ethernet 0/0 interface to be my LAN interface for all my lab machines. And I want my fast Ethernet 0/1 to be my WAN. So basically how my lab machines will get out to the production network. They'll use fast Ethernet 0/1. So to set this up, we want to go first to our LAN side. We'll set this up with IP address 192.168.2.254. We'll give it a /24 mask. Enter, and this is our inside private address, so IPNet inside has to be put on there. And then we'll say no shutdown. And that will bring the interface up. And there we go. You want to see change state to up when it's functioning properly. From there, we're going to do interface F0/1. This is our WAN. We're going to do IP address DHCP, because we have a DHCP server on our production network. We're going to also say IPNet outside. That way, this is the outside part. And we're going to say no shutdown. And this interface should come up. And 2 more seconds. There we go. Now, we're going to exit out of here back to the main mode. And we want to say, since we want to NAT the traffic, we're doing something called PAT, Port Address Translation. It's sometimes called NAT overload, but what we're doing is, and actually we just got our lease from the DHCP server. We're taking, in this case, the 192.168.0.173, and with all the machines that are going to be here inside of the 192.168.2.0/24 network on our LAN side, we want all those machines to appear to be coming from 192.168.0.173. Now, in this case, this is just more of convenience, and plus, if I didn't do this, my existing production network wouldn't have a connected route to get back to the lab. I'd have to run a static route or a routing protocol or something. And I just don't want to do that. I'm going to keep things simple. So what we want to do from here is tell iOS what traffic it needs to rewrite, what traffic to be interested in. We're going to do access-list space 1. So we're making an access list. After that, put a permit on there. And this is a standard access list because the range falls between 1 and 99. So we're going to say 192.168.2.0 and then a wildcard mask, which is the inverse of a net mask, of 0.0.0.255. Hit enter. And then if we say do show access list 1, there is our entry, and that's good. And what we want to do now is set up the mapping of the access list to the address to be rewritten. So we're going to say IP NAT inside source. The source can be multiple things, but in our case, we're using an access list. So list We're going to say 1 for the one we just wrote. And then we want to, since it's DHCP, the address could change, especially in a production environment where you're connected to a service provider. And here we're going to say interface F0/1 for our WAN. Okay, so even if this changes, we won't have to rewrite this rule. After that, we need to say overload. If we didn't say overload, it would want to only allow the first computer use of the 192.168.0.173 address. In our case, right now, it would only allow the first computer to do that because overload tells it to distinguish each unique connection through the router with a different source port number. If we don't put overload on there, it will just let one share all 65,536 ports on that machine, 535. But it would let it share all of them for it. Not share them at all, it would use it all for itself. But we need overload there, so it does. We're going to hit enter on this and do a do show IPNAT stat, short for statistics. And with our IPNAT inside and outside interfaces, those are set just fine. And our access list 1 interface fast Ethernet 0/1 at the bottom is working good as well. The last thing we want to do is set up a DHCP server. So we're going to say IP DHCP pool lab and say network. This will be our LAN side, so fast Ethernet 0/1. I'm sorry, 0/0, 2.0. And this is a normal net mask. And then we're going to say default dash router 192.168.2.254. Give it a DNS server. 4.2.2.1 is fine for our case. And then we want to exit and do IP DHCP excluded dash address. We want to exclude the LAN address 2.254. Hit enter on that. And now that all this is done, we will be able to, let's hit end, type end, and exit out. And if we go to our network manager, should be able to get an IP address. It's taking a little bit here. Let's make sure all of our interfaces are up. They both say up. Oh, there you go. It just took a little bit. Okay. If we do show IP DHCP binding, let's make sure. Yep, my computer got an address. And as you see, though, it's not on NTP or anything. So it's 93. What we'll do at this point is just open up a terminal on our host, do a netstat.rn. We want to verify our gateway. And it's there, and our default static route is there, and our connected network. We'll go ahead and ping from here, ping Google. And if we go back to our router to verify our NAT configuration, if we do show IP NAT trans, short for translation, we can see here the ICMP entry over here in the middle. And quick rundown, it's helpful information to know this. Inside local is inside the private side addresses before they're translated. Okay, so 2.1 is what my computer got. The inside global is the address and the port number after translation. So 192.168.0.173 and the port number. And outside local and outside global are the destination address. Is the destination address before and after translation. Alright, so that's what those mean, and that's how you monitor your NAT statistics. But this is how we make a basic lab router. Now my routers are set with a configuration register of 0x2142. All that means is they just ignore any configuration in the startup config file. If you wanted to save this and you have lab equipment, your equipment would probably be set as the normal register. So we would just do a copy running -config space startup -config, hit enter, and then you hit enter one more time to confirm that. But in a nutshell, that would make it so when this router reboots, it reads its startup config and will come up with all of these. If we do a show run real quick, just as a basically summarize it, it'd come up and would run these commands one by one. That's what a config file is in the case of iOS. It just runs them one by one and sets all those things up we did just automatically. So that's a quick run through of how to set up a Cisco router as a little bit of a lab device. Don't copy these command for command in a production environment. Some things obviously will work the same. The NAT will work the same in a production environment, but there's more things you need. You need access control in your console lines, your aux lines, your VTY lines, and you'd also need more firewalling and even something like CBAC where you have a stateful firewall. So do not just throw these on a production router and plug it into your internet connection. You're not going to have as much security as you think you do. So you got to be very careful about that. But that's the main thing, and that's how we get it working. I hope you enjoyed this one. I'm Tyler with T-Tech, and thank you for viewing.